So let's dive into a discovery that could totally rewrite the book on how artificial intelligence actually works. It points to a hidden order in what we've always assumed was just pure chaos.
Just think about that for a second. The common wisdom has always been that training an AI is this super unique journey for every single model. But what if that's not the whole picture? What if there's a secret, common thread that connects every single one of them?
To really get why this is such a big deal, we gotta look at how we thought things worked. When an AI learns, right, it's basically tweaking millions or even billions of these tiny internal dials we call weights. The general idea was that this whole process is chaotic. Every model starts from some random point and then has to carve its own one-of-a-kind path to becoming intelligent.
What we're seeing now is a complete 180 in our thinking. We're going from this idea of every AI being a totally unique snowflake born from a random storm to a new reality where it looks like they all follow a shared fundamental blueprint. It's a huge shift from chaos to a hidden underlying structure.
So what is this shared pattern? Well, researchers have started calling it a universal blueprint. The more technical term is a universal weight subspace. And what it suggests is that different AIs are way more similar on the inside than we ever imagined.
Okay, I know that sounds super technical, but stick with me. The core idea is actually pretty straightforward. It means that deep inside the incredibly complex wiring of these AI models, there's a surprisingly small and efficient set of pathways for learning. And here's the kicker. Different AIs, even ones trained for completely different jobs, all manage to find and use these exact same pathways. Here's a great way to think about it. Imagine thousands of trains all leaving from random stations scattered across the country. The old way of thinking was that they all took completely different winding routes. This new discovery is like realizing that almost all of them, no matter where they started, eventually pass through the same grand central station to get where they're going. It's a shared central hub for learning. All right, so this all sounds great in theory, but where's the proof? Let's peek under the hood, because the scale of this research is, well, it's massive. We are not talking about a theory based on just a handful of models here. Researchers analyzed over 1,100 different fully trained neural networks to see if this pattern was for real. And the variety here is really the key. They looked at 550 language models. We're talking different versions of things like Mistral and Llama. Then they studied 500 vision models, like the vision transformers that understand images. And you know what? They found the same convergence, this same blueprint in all of them. It's a pattern that goes way beyond what the AI was even built to do. So how'd they even find this? Well, they developed what you could call a mathematical X-ray, a technique called spectral decomposition that let them see the internal structure of the AI's brain. It allowed them to map out the pathways the AI used to learn, and they discovered that a ton of the important information was consistently organized in the same simple, shared structures. Okay, so this is where it gets really exciting. This is way more than just a cool academic finding. Discovering this universal blueprint could literally give us a whole new playbook for how we build and use AI. I mean, the potential here is huge. If we know where that grand central station is, we can probably build AI that gets there faster, using way less energy. We can merge different specialized AIs much more easily, creating some really powerful new combinations. This could totally change the game for multitask learning, and this is a big one. By making training more efficient, we could seriously cut down on the massive environmental footprint of AI development. And hey, don't just take my word for it. The researchers themselves put it perfectly. They said this inherent structure has major implications across the board for making AI more powerful, reusable, and just plain efficient. So where does all this lead? Well, it opens up a really mind-bending question about the future. What if we could use this knowledge to find the ultimate shortcut? Now, this is the next great challenge. Right now, we still have to train a model for it to find this efficient pathway. But what if we could identify it from the very start? What if we could just tell the AI where Grand Central Station is, instead of making it wander all over the country trying to find it? And that right there is the ultimate question this leaves us with. This discovery might just be the first step toward a future where we can create incredibly powerful AI without the brute force approach we use today, without the massive data sets and the colossal computing power. A future where we build AI with precision, not just raw power. And if we can do that, well, that could change absolutely everything.